Now that we've looked at how to draw intervals on a number line, we'll next look at how to write interval notation, which is a shorthand method to quickly write down these intervals when drawing isn't an option. So here's the shorthand method. Over here, we're saying that if we're looking at the start of an interval where the number itself is included, we have a square bracket. Otherwise, if it's excluded, we have a curved bracket. Similarly, if we have the end of an interval where the number itself is included, we have a square bracket again, or a curved bracket if it's excluded. So, how can we apply what we already know to the new information that we've learned? Say we have an interval from 2 to 3, like this. If we were to use the new notation, we would draw it on the number line like this, from 2 to 3, like this. However, in real life, we only use this notation for drawing on the number line. We never use this one. Instead, we use this one when we're writing down the interval itself. So we're not drawing it, we're just writing it down. So it would look like 2, 3, like this. And this interval show the same thing. Another example would be an interval from 3 to 7, which using our new notation on the number line would look like this, from 3 to 7. However, we never use this notation on the number line. We only use this one. So as interval notation, this one would be 3, 7 instead. So now, how do we remember which bracket is for which? The way I remember them is that include has a straight line in the eye, and the square bracket also has a straight line, and exclude has an E which is curved like this, and so does the curved bracket, like that. So the way to remember it is to just think of the word include and exclude, and it will tell you which bracket to use. Now we'll look at the connection between inequalities, signs, and intervals. When we say that x is greater than some value a over here, what we're saying is that this value over here, above which on the number line we would draw an unshaded circle, that value in this case is a. It's the smallest value that we could have in the interval. And x could be any value in this interval moving forward from a, or that are greater than a, but not including a. Any of these could be x. And similarly over here, we could write it as a, x, and we could have either a curved bracket or a square bracket, depending on how our interval is ending. So this is how we can relate inequalities, sign, and the interval notation that we have all together. I'll go through a few more examples. So over here, if we have a b, then we're saying that this value is b. And x could be any value less than b, but not equal to b. So any of these could be x. And when we're writing the interval, we would have something like either a square bracket or a curved bracket, and we would have x and we would have b. Notice the smaller value always comes first and the larger value comes next. So we cannot have an interval in this scenario where b is more than x and we have b, x. This would be incorrect because b is more than x. Let's look at another example. Over here, if we have x is more than c, we're saying that this is c. And x could be any value greater than c. And we can write this as c, x with either a curved bracket or a square bracket. And the same logic applies for this one. Now, we have names for these intervals or different kinds of intervals. Let's look at those next. These are the different types of intervals that we can have. We can have an open interval where neither a nor b is included in the interval. So therefore, we have x is more than a and x is less than b, but x is not equal to a or b. Or we could have half open intervals, also called as half closed intervals, where one of the starting value or one of the ending value is included. And finally, we can have a closed interval where both the starting and the ending values are included. And these are the different names of an interval. So if you see these names in a question, then you must think about these kind of intervals. So for the final part of this video, we'll look at infinite intervals, which are intervals where we can include infinity. And I'm saying include with quotation marks for now. So before we look at how we can include infinity, we look at what infinity is. Infinity is something that represents an unbounded growth. It shows something that goes on forever and ever. That could either mean that it's going on forever in the positive direction, meaning a really big number, or something that's going on forever in the negative direction, like a really small number. It's a value that we cannot actually reach. This means that because we cannot actually reach infinity, we can't actually include it in an interval because it's not a real number. It's just an idea of a really big number. So whenever we try to include infinity, and I'm saying include with quotation marks because we can't really include infinity. What I mean by include is that we write down infinity in an interval. So whenever we write down infinity in an interval, we must write it down with curved brackets because we're showing that infinity is not included in the interval. We cannot really reach it. So over here, on the negative side, we have a curved bracket because we're going towards negative infinity, but we're not reaching it. And on the positive side, we also have a curved bracket because we're going towards positive infinity, but we're not reaching it. And over here, we're saying that a is not equal to either plus or minus infinity. And because we're saying that, we could say that, okay, we could have had a curved bracket over here, or we could have had a square bracket over here. Similarly, over here, we could have had a square bracket or a curved bracket. Whatever we chose is just by choice. We could have either ones. But for these ones over here, we must always have a curved bracket because infinity cannot be included. And finally, I'd like you guys to try these questions and we'll go through them in the next video.